is our third week, okay, looking at trig. So first week we looked at some basics like how you convert between degrees and radians. That was important. The second week we did unit circle trig. So I was using the 30s and 45s and figuring out the 6 trig functions of those special angles. And now we're going to look at doing what's called inverse trig. So some people have already seen the button, or they've asked me about it. Like if you press second and sine, you get that sign with a -1. What does that mean? Okay, so that's what we're going to look at this week. That's called inverse trig. And specifically, that one was inverse something. Okay. So the idea of inverse trig is it basically gives you a way to undo or reverse what we did last week. Usually when we do something in math, there's always a way to undo somehow, okay? Unlike real life. But there's usually a way we can undo something that we've done. So for example, if we take something like 8 and we double it, we can undo that by taking half of it. And it gives us back what we started with. Same thing if we take the number 5 and we square it. Well, we can get back what we started with by doing the operation that is the inverse of squaring. And what undoes squaring? Yep.
Square root.
Yeah, we can square root. And you get back what you started with. Right? Same idea with trig. If I take the sine of, let's just do something in degrees. Let's take the sine of 30. Okay, we get 0.5. Now, if I take the inverse sine of 0.5, it gives me back 30. Puts me back with what I started with. So it gives us a way to undo a regular trig function. That's what inverse trig does. Okay, so how does it look when you write inverse sine? Well, we generally don't write out the whole word, like inverse sine. Okay, there's an abbreviation we use, and there's 2 different abbreviations. The one that I'm going to use most of the time is these trig functions, and it looks like there's a -1 up a little bit higher. Okay, first thing to understand about this abbreviation is it has nothing to do with raising something to a -1 power. Okay. Does it look like it's a -1 that's an exponent? It does. But it has nothing to do with raising something to the -1 power. When you write a trig function and you put a -1 up a little bit higher, it just means inverse sine. That's all it is. It's a special symbol for inverse sine. Now, what makes that a little more confusing is if you put a number there that's not a -1, like 2, then that is an exponent. Okay? So when you put something in this spot other than a -1, yes, it does mean to take sine and raise it to the second power. But when you put a -1 in that box, it's kind of a special case. It just is a symbol for inverse sine. It has nothing to do with an exponent. Another way you might see inverse sine written is arc sine. It means exactly the same thing. Okay, same thing for inverse cosine and inverse tangent. You might see arc cosine or arc tangent. They're just different abbreviations for inverse trig. Okay. Now, if you notice, there's 3 missing. We've talked about 3 other trig functions besides sine, cosine, and tangent. We've done secant, cosecant, and cotangent. You can do inverse trig with those. It's just not something that we really focused on in this class. All right, so first, any question on the abbreviations? Okay. And we'll do more of this, but again, how you get to it on the calculator is you press second, and then you can press one of the 3 trig functions. That's inverse sine, that's inverse cosine, and that's inverse tangent. So you just press second. Okay. If you do this, if you take sine and then you raise it to the -1 power, that is not the same thing at all. Okay, raising to the -1 power is totally different. So just get that idea in your head that this -1 is not an exponent. It's just a special symbol. All right, so I'm going to come back to that. I want to show you something else first. First, I want to just kind of compare how what we're doing this week is different than what we did last week. This is the kind of question I would have given you last week on the test. I gave you that number right there, which was an angle, and then I would say, okay, find the, and then I give you a trig function. Okay, find the sine of 30 degrees. Find the cosine, find the tangent. Right? But I would have given you that number right there, and you would have told me the question mark. Okay, that's what we did last week. This week, it's the opposite. Instead of me giving you the angle, I'm giving you the answer to the question. I'm telling you that there's something you can take the sine of, and the answer will come out to 0.5. You have to figure out what is the thing that you can take the sine of and get an answer of 0.5. That's the difference this week. Okay, so last week, I gave you the angle. This week, you're going to tell me the angle. That's the difference. Yeah?
Can I just, they didn't give me the pass, so I can go out to my car to get my ankle brace. Can I just go get that?
Oh, yeah, they gave you a pass?
Yes.
Okay, yeah, just sign up for me. So the other thing is that should give you kind of a hint at when you use inverse trig. Inverse trig, bless you, is always used to help you figure out the angle or find the angle. That's what inverse trig is used for. If you don't know an angle and you need to find it, you use inverse trig. If you already know an angle, then no, you don't use inverse trig. Okay? So if you're given an angle, you're usually doing something with regular trig. If you need to find an angle, that's inverse trig. So where's that kind of thing going to come up? Well, eventually, probably on Wednesday, we're going to talk about solving triangles. And I'll give you a couple sides in the triangle. And then I'm going to say solve and tell me how big that angle is right there. Well, the only way to figure out how big that angle is to use inverse trig. Inverse trig is used any time that you need to find the angle. So that's eventually what we're going to do with it. Any question on that? Okay, so now let's go back and let's fill out this chart and see what happens. Okay, so what I did is I made a chart and I picked some different angles. I just picked 30, 65, 90, 150, just pick some random angles. And what I want to do is plug each of those in on the calculator, just write down the answer we get. So let's, first thing is if I'm going to type these in, they all have a degree symbol on them, so I need to make sure that my calculator is in degrees. Okay, so I'm going to take the sine of 30, and I get 0.5. Okay, so just going to write these down, see what happens. Sine of 65 gives me about 0.91. So now let's think about these two. If I take the inverse sine of 0.906307, I'm not going to type it all in, but if I take the inverse sine of this number, when I hit enter, what answer should I get back?
65.
Yeah, and I get about 65. I didn't type it all in, but I get 64.999. That's 65. Okay. So let's type in sine of 90, and I get 1. So now if I do inverse sine of 1, what number should I get back? At this time I'll get exactly 90 because that's exact, it's not rounded. Let's do 150. 0.5. That's a little bit of a problem now. Does anybody see why there's a problem there now? Yep.
I think we were going up each time, but now we're back to 0.5.
Okay, so yeah, we got to repeat. So now the question is, when I do inverse sine of 0.5, well, is it going to give me the 150 or is it going to give me 30? It can't give me both. There has to be one answer to this problem. If there's not one answer that we all agree on, that's a problem, because then we're going to have different answers for the same question. So we need to come up with a way of what answer are we going to agree on. Why didn't we get the 150? Okay, it's not that the 150 is wrong when we do inverse sine. It's just that when you do inverse trig, you have to get a single answer. Right? So we got to come up with a way to agree on what we're going to use. Okay, so let's take a look at that picture. Okay, so there's a picture of what sine looks like. We haven't studied the graph of sine too much yet, but it looks like a wave. Okay, and what I've done is I have a horizontal line, and I'm going to put it right there. Does that horizontal line hit the graph more than once?
Yes.
Yeah. That's the same problem that we have here. Getting this answer more than once basically means you can draw a horizontal line and it hits it. In fact, it hits it infinitely many times. Right? If I just keep drawing that wave forever. So I could type in like sine of, let's do 390. There's another answer that's 0.5. Right? I could do sine of, let's do 510. There's another answer that's 0.5. I could type in infinitely many answers, and they would all come out to 0.5, as long as I picked the right numbers. But when you do the inverse sine, you don't get any of these other ones back. So the way that we kind of figure out what answer we're going to get back is we're going to block off part of that graph. Okay? We're going to hide part of it. And what we're going to do is we're only going to look at a part that passes the horizontal line test. To pass that test, it means I need to find a section, the biggest section I can, where that horizontal line only hits the graph once. Okay? It cannot hit it more than once. So let me make kind of a window here. Let's go like that. Oh. Might run out of paper. Yeah, I gotta get more. That's okay. I'll get it. You're good. All right, so let me put that. Okay. And what I'd like to do, I want to kind of group those two things together, if I can. All right, and I'm going to focus on what is between the two boxes. So I made those exactly 2 tick marks wide. I don't know if you can tell, but it is 2 tick marks wide. So now, if I look at the section between the boxes there, does that section pass the horizontal line test? Like, does the horizontal line only hit the graph one time? Okay, so that's not a good section. Let's try like another section. I want to look at a positive section. How about that section? No. How about that section between the boxes? Yeah. So that's basically what we do to avoid the problem of having more than one answer. We say, okay, we can't look at the whole thing, but we could look at part of it. And if we look at the part between those two boxes, that horizontal line will never hit more than once, right? And that's basically how they solve the problem of having more than one answer. We all agree to look at just that part. Now, that's not the only part. You could look at that part. That part would also work. This part over here would also work. Any section that you can find that only hits once would work. But we all have to agree on the same section, otherwise we're still all going to get different answers. So when we're dealing with inverse sine, everybody agrees that the answer that you give to an inverse sine problem is always between -90 and +90. As long as we all agree to stay between those numbers, we will never have an issue. Okay? And if I bring the graph back up, just move that for a second. This mark right here, that's -90. And this mark right here is +90. So we basically focus on that box right there. And that's why, because -90 to 90 passes what we call the horizontal line test. Little different than vertical line test. Same idea, just with a horizontal instead of a vertical. Now, that's sine. Okay, that's the graph of sine. If I put in the graph of cosine, let's see what happens. If I drew a horizontal line with cosine, would it hit the graph more than once? Yeah, we have the same problem, and you might look quick and say, wait, that's just the same picture. No, it's not quite the same picture. The graph of sine goes right through the origin. The graph of cosine does not. It's at its high point there. So if we tried the same trick that we used here, and we did one tick mark to the left, one tick mark to the right, and we look at that box, that's exactly the same place I put the box on sine. Does that work for cosine? No. So what we're going to have to do with cosine is we're going to have to slide the box a little bit. Okay, we're going to look at that section. That's 0. Does anybody have a guess what the edge of that box is at?
2.
Well, remember, each tick mark, that's not 1, that's 90.
180.
It's 180, yeah. So as long as we all agree to give an answer when we're dealing with inverse cosine between 0 and 180, we will avoid that problem of getting more than one answer. Right? So I'm going to put all of these on the board. And this shows you, when we're dealing with inverse trig, the different answers that we're going to stay between. Okay, so any questions on those different intervals that, if we have a choice of more than one answer, that's what we're going to do. Notice, you might look at the inverse sine and inverse tangent, and they might look the same, but notice the -90 to 90 on inverse tangent doesn't have the equal to under it. That's because it will never equal 90. And the reason why is, think back to the unit circle for a second. Okay. Here's your unit circle. Where's 90 on the circle? Yeah. It's at the top. Does anybody remember what the coordinate is for 90? 0, 1. And now the formula for tangent, it was a fraction. Does anybody remember it was something over something? Yeah?
Sine over cosine.
Sine over cosine, or how about in terms of the letters? Yeah? Right, y over x. Sine over cosine is also correct. Try to take the tangent of 90 and watch what happens. Y is 1. X is 0. What happens if you divide by 0?
You can't.
You can't. That's undefined. That's why you can't equal 90 degrees and do the tangent. Okay? Same with -90. You'd be trying to divide by 0. That's why there's no equal to there. Okay? All right. So I did that. I went through that, and now we're here. All right, so now we got to figure out, when do you use this chart? Okay. Well, this chart doesn't have every single angle on it. This chart only has angles that are multiples of 30 or 45. That's the only time you can use that chart. When the answer is going to come out to an angle between 30 or 45. But that's kind of the problem. Like, how do you know what the answer is going to come out to? That's what you're trying to figure out. You don't know the answer. Okay? So like, how do you know if you should use the chart on that problem? Well, the way I explained it is I said you should use the chart if you know that's going to come out to a 30 or a 45. The way you know that is you look at that. If you see numbers like 1, -1, a half, root 3 over 2, root 2 over 2, square root of 3, any numbers like that or they're negatives, those are the kinds of numbers that are going to be in the chart. They're all the numbers we did last week with unit circle trig. So 1s, -1s, 0s, halves, all those numbers. If you had a problem like, say, inverse tangent of 0.756, well, you're not going to find a 0.756 anywhere in this table. Nowhere does it say 0.756. And that's because when you do this problem out, the answer to it is not going to be a 30 or a 45. Okay. So I'll talk about how we type that in on the calculator after. So that's not a problem we would do on the chart. So remember, this thing right here, that's called the argument. So you look at that and see if it looks like one of these numbers. In general, it just has to look like one of these numbers. Anything with like a root 2 or root 3, you can look at the pattern of numbers you see there. There's not a lot of different numbers, really. If you look at them, like root 2 over 2, it's repeated all over the place. So it's not like it's hundreds of different numbers. It's probably like 20 different numbers in that chart. A lot of 1s and -1s come up. Yeah, print okay?
Yep.
All right, so let's try an example. So we're going to find the inverse sine of 1. Okay, and we're going to use that chart to do it. Okay, first, let me explain that problem a different way. What that question is asking is, what angle can you take the sine of and get 1 as the answer? Those two things mean exactly the same thing, just a different way for me to kind of phrase it. Okay. Solve for the question mark. What angle can you take the sine of, and you'll get 1 as an answer. So what we're going to do is keep in mind when we're doing inverse sine, we want to pick an answer that's between -90 and 90 if we have a choice of more than 1 on the chart. Okay? Always stick with the one between -90 and 90. All right. So what we're going to do is we're going to go to the column where we see sine, and we're going to go down the sine column until we find a 1. Okay, so let me zoom out a little bit. So we're going to go down the sine column until we find a 1. There it is. And I'm going to circle the answers that the chart tells me. All right, I'm going to keep going. I'm going to see if it comes up again. No. 1 never comes up again. So it gave me 2 different answers. Actually, it gave me 4 different answers. 2 in radians, 2 in degrees. Okay, let's start with doing it in degrees. I have 90 and I have -270. Okay, so what I did to get the one in parentheses below is I just subtracted 360. So you have every angle on this chart as a negative and a positive. So you got everything. Would I write down 90 or negative 270? Right, because what two numbers do I have to stay between? Negative 90 and 90. It's not that the negative 270 is wrong. It is correct. But if I ask you for one single answer, we got to agree on what answer we're going to give. And we do the one between negative 90 and 90. And that's also the way the calculator does it. It does it the same way. So that is going to be 90 degrees. Or what if they wanted the answer in radians? What would you say? What is it?
X over 2.
So if we give an answer, we can't have any variables in the answer. We want to make sure that the answer is just a number without any letters.
Pi over 2.
Pi over 2. Yep. So either 90 or pi over 2. Okay. Any question on that one? Now, when I type something like this in on a calculator, I always do it in degrees. Right? Especially if they tell me they want an exact answer. Because if I try typing this in on the calculator, and let's do it in radians. Let's type in the inverse sine of 1. Okay. If I ask you for an exact answer, and you write 1.570796327, that's not exact. Okay, that's a decimal. All right. If you had done the problem in degrees, you would have noticed that it comes out to a nice answer, 90. Now, if I know that it's 90, and I say, well, I want it in radians, don't put your calculator in radians and do it. Just take the answer you already got in degrees and change it by hand. Multiply by pi, divide by 180. How many times does 90 go into 180? Twice. That becomes a 1, that becomes a 2, and you get pi over 2. It's exactly the same thing the chart gave us. And if I type in pi over 2, that is exactly the decimal the calculator gave me. Okay? But the thing is, the calculator won't be able to give you pi over 2. That's the answer that I want, not 1.5707. Okay? So the way to do it is if you need to use a calculator, which this one we didn't, we could just use the chart. But if you need to use a calculator and it says exact answer, do it in degrees first and then convert it to radians by hand. If it doesn't come out nice in degrees, well, then it's not going to come out nice in radians. Okay? So there are some problems. You can't get an exact answer no matter what you do. Right? But if you're going to get a nice answer, you will see it in degrees. You won't see it in radians. Let's try this one. Inverse sine of negative 1. Okay, so that tells you the column. You're going to go to the sine column, and you're going to go down the column until you hit negative 1. So if we go down the sine column until we hit negative 1, does anybody see what angle is in that row?
270.
Okay, so right here. If we're doing degrees. So now, would we write 270 or would we write negative 90? Right, we're going to write negative 90 because you've got to give an answer between negative 90 and 90. Okay, and that's the one. So negative 90. Or, if they wanted the answer in radians, what would you write down for that?
Negative pi over 2.
Negative pi over 2. And that's it. So far, we haven't really had to worry about finding the same answer on the chart more than once. This one you will. Okay. Inverse sine of 1/2. Okay, so let's look at inverse sine of a half. So we're going to go down the sine column. We're going to keep looking at it until we find 1/2 in that column. Can anybody tell me the first time that you see?
30 degrees.
Yep. So if we go down the sine column, 1/2, we got it there. And if we keep going down, where do we see it again? Yeah. So now we've got 4 different answers. Out of the 30, -330, 150, and -210, which answer are we going to put?
30 degrees.
Yeah, we're going to put the 30 because that's between -90 and 90. Now, if you did that problem in radians and you tried typing it in on the calculator, you are not going to get a nice answer. 0.523598. The answer that I would want is pi divided by 6. How did I know that that was that? Well, just doing a lot of these problems. But how would I have figured that out if I didn't know? I could have taken 30 degrees, multiplied by pi over 180. 30 goes into itself once. And how many times does 30 go into 180? 6. That's how I knew it was pi over 6. So anytime you need an exact answer, do it in degrees first, if you need to use the calculator. Let's try this one. Inverse sine of root 2 over 2. So inverse sine of root 2 over 2. Now don't forget what you're really doing. You're trying to figure out what angle can you take the sine of and get root 2 over 2 is the answer. Okay, that's the goal. You're trying to figure out an angle. So let's go down the sine column. And where do you see an angle that you can take the sine of and get root 2 over 2 is the answer?
45.
45. Okay. Let's keep going. Do we see it anywhere else?
130, 35.
Yep. Okay, you'll never see it more than twice. So once you find it twice, you're done looking. Now the answer that we give has to be between what two numbers? If you're doing degrees, -90 and 90. If you're doing radians, it's negative pi over 2 to positive pi over 2. Okay. So out of those 4 that we have circled, which one is between -90 and 90?
45.
45. You'll never have one. You'll never have more than one. Okay? 45 is the only answer. Okay. Any question on that? All right. And now let's try inverse sine of negative root 3 over 2. Okay, so keep in mind what that really means. You need to figure out what angle can you take the sine of and get an answer of negative root 3 over 2. Okay. So where do we see negative root 3 over 2 come up? 2 what? Not for inverse sine. No. Inverse cosine it comes up there, but not inverse sine. 240. And anywhere else?
300.
Let's see, 300. So now you got 4 numbers you're looking at. 240, negative 120, 300, negative 60. Which one of those are we going to write down?
306 or negative 60.
Right, we got to stay between negative 90 and 90, and we're going to write negative 60. Or let's just practice in radians. What would we put in radians? Yep, that would be negative pi over 3. Okay, if I didn't have the chart to figure that out, the calculator would not be able to give me that number. I would have to do that first, convert it by hand, and then I would get that. Any questions? Yeah. On the homework, I think you can probably just stick with, if they give you a direction and say use degrees, then you do whichever one they say. If they don't, you can use either unit. Okay. I think the book mostly does radians, so if there's no direction and you choose to use degrees, then your answers might not match with what I read off tomorrow, but it doesn't mean they're wrong. On the test, I will definitely give you like direction that's clear. Use radians or use degrees. All right, so let's try this one. Inverse cosine of 0. All right, so now we got to kind of switch our thinking a little bit. We are not between negative 90 and 90 anymore. What did we write down you have to be between for inverse cosine? Yeah?
0 and 180.
Okay, 0 to 180. If you use negative 90 to 90, it's going to mess you up. You want to use 0 to 180. Okay, so let's look for 0 in the cosine column. Okay. Where's the first time we see 0 in the cosine column?
90 degrees.
And that's, we already know that is between 0 and 180, so that's going to be our answer. But we do see it again over here. And it still is important to know where that second answer is, because in another problem, that might be the one you need. In this problem, it's not. So between 0 and 180, we're going to go with 90. Okay, 90 degrees. Any question on that? And you can check it, because if you plug it in, you should be able to take the cosine of 90. And if I did it right, when I hit enter, what should I get? Yeah, well, actually I'm in radians. Make sure you put it in degrees. When I hit enter, I should get 0. That confirms it's good. All right, let's try inverse cosine of negative 1/2 and inverse cosine of negative root 2 over 2. So I'm going to let you guys write those down first, and then I'm going to put the chart up. And I want you to try those two. So negative 1/2, negative root 2 over 2. All right. Let's see if you can take a minute and figure out those two.
Was it negative?
All right, so let's take a look at the first one. How about inverse cosine of negative 1/2? Anybody think they got that one? Yep. All right, so let's go down. Cosine column, negative 1/2. Okay, you see that answer right there? And I can stop there because I know I'm looking for between 0 and 180. 120 fits that. So if I see negative 1/2 again, anywhere else, it's not going to work. Because I already found one that does. You're not going to find a second one that works. So 120 is correct. If they wanted degrees. And if they wanted radians, that's going to be 2 pi over 3. So there's two ways to figure that out. Either convert that, like I just did, or look at the chart and get the answer that way. Okay, so that's the first one. How about inverse cosine of negative root 2 over 2? Anybody think they got that one? Yeah. 100 and how much?
35.
All right, so let's go down. Negative root 2 over 2. I found one between 0 and 180. I can keep looking, but I'm not going to find another one. All right, so looks like negative root 2 over 2 is 135. Okay. Any questions on that? All right, and let's try, just do a couple with tangent. Now you're going to notice something different about the tangent than any of the other ones. They are the first one we've talked about today that has like undefined. We talked about 90 and why you can't do 90 because you'd be dividing by 0. If you try to look at 90 on your chart and you go to tangent of 90, it says undefined. Those 4 that I just underlined, those are the only 4 that will have undefineds. You will never see undefined in the sine or the cosine column. But the last 4, you'll see it pop up in different spots. And everywhere that it pops up, it's because you are trying to divide by 0, if you want to think of it in terms of what we learned last week. All right, so let's try inverse tangent of root 3. Okay, so first thing, we want to make sure we remember what we're between again. Okay, so now what are we looking to stay between this time?
Negative 90 and 90.
Okay, back to negative 90 to 90, but it never will be exactly negative 90 or 90. Okay. So how about inverse tangent of square root 3? Yep, so you're going to see it here. You will see it again at some point over there. But those 2 answers over here, these are not between negative 90 and 90. Over here, 60 is between negative 90 and 90. Yep. So that's the angle that you could take the tangent of. If you took the tangent of 60, you would get square root of 3. That's the answer, 60. Make sure anytime you put an answer in degrees, you put the circle on it. If you don't put the circle, it's radians. Okay, and inverse tangent of negative root 3 over 3. Anyone think they see that one? And make sure you give me the answer that's between negative 90 to 90. Yep. Yep, negative root 3 over 3. Pops up a couple times. The first time it pops up, the answers don't fit what they're supposed to. So we're not using those. The second time it pops up, negative 30, that's what you're looking for. Okay. Or if you're doing it in radians, that's negative pi over 6. So either use the chart to figure that out, or convert negative 30 to radians by hand. All right. So any questions on using that chart? Okay. Now, all those angles on the chart are multiples of either 30 or 45. And there's some overlap too, like 90 is both. But if we have a number that's not in that chart, then we use a calculator. So I want to do the inverse sine of 0.65. If you're not sure if that's in the chart, well, go to the sine column and look for 0.65 in the sine column. You're never going to see a 0.65. It doesn't come up. So for something like that, we're going to use the calculator. And most of these are not going to come out to nice answers. So we will round to 2 decimal places. How do I get inverse sine on my calculator? What do I have to press? Yep.
Second and then sine.
Second and then sine. Now, this question is a little bit vague in the sense it doesn't tell you whether to use degrees or radians. So you technically could do either one. If you want degrees, it's 40.54. Now, since I did not get a nice answer in degrees, it doesn't matter if I just type it in radians on my calculator. I didn't get a nice answer either way. So if I always am going to get a messy answer, then I'm not going to convert this to radians by hand. It's not going to do anything for me. I'm just going to type it in again and change to radians. I would not want to do what I just did if this answer came out nice, okay? But it didn't, so it's fine. It's also 0.71 radians. Okay, if you check your answer, remember when you type it back in, it's probably not going to come out to exactly 0.65 because we rounded. Okay, we only rounded to 2 decimal places, so we got 0.651. Okay. Probably would be a little bit more accurate with the degrees. We can check it. Yeah, that's a little bit more accurate. And the reason the degree one was more accurate, even though they're both rounded to 2 decimal places, is degrees is a naturally smaller unit of measurement. Because it's naturally smaller than radians, it's automatically more accurate when using the same amount of decimal places. It's like if you round something in miles to 1 decimal place, or you round something in inches to 1 decimal place. Well, inches is going to be automatically more accurate because it's a smaller unit. All right, let's try this one. Negative 0.24. Is that a number that we're going to see in the cosine column on the table? Nope. So we type it in. Second inverse cosine. And we get 103.89. And I know I did it in degrees because if I look at my calculator, it says degrees on it. That's why I put the degrees in. Nice. And let's try inverse tangent of 34.3. It's like sleepy time. All right, inverse tangent of 34.3. Is 34.3 a number that we see on the table? No. So you've got to do that one with a calculator. And that confirms it's not in the table because the table only has multiples of 30 and 45. 88 is not a multiple of 30 or 45. So it's 88.33 degrees. Question on that? All right. Now, I know I've shown it a couple times, but I want to just write it one more time because you're going to need this in the last problem we do. This really means the tangent of what comes out to 34.3. And we know that it's now 88.33 degrees. So you just solved for the question mark. We don't have a secant, a cosecant, or a cotangent button. So if I give you something like, let's just try inverse secant of 1.3. Well, if we had an inverse secant button on the calculator, we'd just do it the way we did all the others. Second inverse secant and hit enter. We don't have that. Okay, so let's think about this a different way. How can I rewrite this the way that I rewrote this one right here? I want to turn what's on the left into something that's on the right. You can tell me how to rewrite that. Yeah. Secant of what is going to come out to 1.3. Now, we don't have a button for secant, but we got rid of the inverse when we rewrote it that way. That's regular trig. What we started with was inverse trig. We know secant is connected to another trig function. Does anybody remember from the unit circle? What trig function is secant connected with? It's connected with cosine. what is the connection between the two? If you know one of them, you just have to do something to it to get the other one. It's what?
It's flipped.
It's flipped. So if we know the secant comes out to 1.3, that's the same as saying the cosine comes out to not 1.3, but what? So if the secant is 1.3, then the cosine is,
Negative 1.
no, we didn't say anything about making a number negative. That's not the connection between them. Yeah?
Is it 1 over?
It's 1 over 1.3. Okay. Now we say, well, what's the advantage of doing that? Well, now you've turned it into a trig function you have a button for. Now, take what you have here and rewrite it back this way on the left. But now it's going to have inverse cosine instead of inverse secant. So how would I take that and convert it back into something like this? Yeah?
Inverse sine of,
Inverse what?
inverse cosine
Inverse cosine of,
of 1.
yeah. And that's what I want to know. So the trick is, if you have one of these three, first thing you do is change this to the one that it's connected to. If it's inverse secant, that one's connected to inverse cosine. If it's inverse cosecant, that one's connected with inverse sine. And how about if it's inverse cotangent? Inverse tangent. So that's the first step. Change it to the one that it's connected to. The second step is to take that number and flip it. That's how you do these other three on the calculator. Change the trig function to the one it's connected to and flip the number. Okay. So to type in this one, we're going to do second, change the trig function to the one it's connected to, flip the number inside. So it's kind of like what we did last week with flipping. Last week we flipped the whole thing. This week you're just flipping the number inside. So it's a little different. 39.72 degrees. Okay, that's the answer. All right, let's try it on this one. Okay. Do I have a button for inverse secant? No. So then I need to change it to the trig function it's connected to. Which one is that connected to?
Cosine.
Yep, so inverse cosine. And what do I need to do with the number on the inside?
Flip it.
Flip it. It's not hard, you just have to remember what to do. It's 46 point, if we round that up, it's 46.40. Let's try this one. Do we have inverse cosecant on the calculator? No. So we got to change it. What trig function is that one connected with? So second, inverse sine. And what do we do with the number on the inside? Flip it. That's how you have to type that problem in. It's 22.662 if we round up. And last one, inverse cotangent. Do we have a button for inverse cotangent? No. So what trig function is inverse cotangent connected with?
Inverse tangent.
So we're going to do inverse tangent. And we're going to take the 0.35 and
Flip it.
flip it. So remember what you're doing. You're trying to find an angle that you can take the cotangent of and get 0.35 as the answer. And the angle is 70.71. That's the answer. Okay, so now you know how to do the inverse trig if it's one of the three that you don't have a button for, or if it's one of the three you do have a button for, or if it comes out to a nice answer, now you know how to use that chart. Okay. Any questions on that? So you will need a calculator on quite a few of them. At the beginning, you'll need that chart. It's 13 to 17, 19, 20, and then 22 to 31 and 33. And you've got about 15 minutes left, so please use the time to try to get a little bit of that done. And if you get stuck on anything, let me know and I can come help you.